Today's lesson is really an extension of yesterday's lesson where we were factoring trinomials of the form 1x squared plus bx plus c. The only difference today is we're going to look at examples where that number in front of the x squared term is not just a 1, it could be other numbers instead. So our warm-up today is just one question. I'm asking you to expand and simplify this. So this is the case where you're going to take every term in the first bracket and multiply it by every term in the second bracket. So the 2x would multiply the x minus 2, and then the minus 3 is going to multiply the x minus 2. So that's the expand, and then the simplify is the collecting of the like terms. So try that for these 3 examples, and then take a look at your end answers for each one of those and see if you can see connections back to what you had in the original brackets. Make sure you put the video on pause and try it out first, and then check. Okay, so check your answers and make sure that your final answers match my final answers. And then let's look at some patterns that we notice. Based on what we talked about yesterday we were looking when we started with an answer like this and we wanted to work it backwards into its factored form, so a bracket times a bracket, we were looking for 2 numbers that would add to the middle term. So for example, the 7x, the minus 7x, comes from the sum of a minus 4x with a minus 3x. And likewise, this plus 17x comes as a sum of plus 2x and plus 15x. And this 7x plus 7x here is the sum of the minus 3x with the plus 10x. So we need to find 2 numbers that are still going to add to that middle term, so adds to negative 7, and multiplies to the product of the outsides. So if I take 2 times 6, 2 times 6 is positive 12. Now we always start with our multiplying numbers, and for those people who multiplying facts don't come easily, I suggest just being methodical about this might help. I would start with my multiplying number, and I know 1 times that number would multiply to 12. Okay, that's supposed to be a dot in between for a times sign there. Let me just erase that and try that again. So it's a 1 times 12 would equal 12, or 2 times 6 would equal 12, or 3 times 4 would equal 12. Now, when I multiply to a positive number, I know that the sign of my 2 numbers have to be the same. They either are both positives or both negatives. And since I'm adding to a negative, that tells me that they're both negatives. So I'm looking for the combination that when I add them together, I get negative 7, and that negative 3 and negative 4 are the numbers that work. So those are our 2 numbers that we have to use to break down or decompose our minus 7x. Okay, so the same things that we were doing yesterday still work for today. If I look at part B, I'd be looking for 2 numbers that add to 17, but at the same time they have to multiply to the product of 5 times 6, which is 30. 2 numbers that multiply to positive 30 and add to positive 17. We can try 1 times 30, but they add to 31. And 2 times 15, they add to 17. So there's the combination right there, and you'll see it's a plus 2x and a plus 15x to break down that 17x. And then working backwards, you can see these have been paired up. They have 2x in common, and when you factor the 2x out, you're left with a 3x plus 1. If you look at the second pair, the 15x, the plus 5, 5 is common to both, and you're left with a 3x plus 1, making the 3x plus 1 common, leaving you with the 2x and the plus 5 in the other bracket. All right, so it's working backwards. We're just extending our skills from yesterday. The last one, we'd be looking for 2 numbers that add to 7 and multiply to 30. So if we look at what we had in the previous example, we were multiplying to 30. 1 times 30 adds to 31. 2 times 15 adds to 17. We could continue on and do a 3 and a 10, and I just realized I made a mistake. 3 times 10, and hopefully you caught the mistake. This plus here should actually be a subtract. So we're actually multiplying to a negative 30, which means my 2 signs have to be opposites. One's a positive, one's a negative, so I multiply to a negative answer. And because we're adding to a positive 7, it means the bigger number has to have the positive and the smaller number is the negative. So whatever you're adding to when your signs are opposite, that is the sign of the larger number. So this is the combination that would add to positive 7, and you can see that works out. We've got the minus 3x and the plus 10x, and if we pair the first two together, they have a common 3x, so we common factor 3x out, and we have a 2x minus 1. Out of the second pair, we have a plus 5 in common, take out a 2x minus 1. Here's your 2x minus 1, which multiplies the 3x and the plus 5. Okay, so that's a recap of what we did yesterday. It's just we don't have a 1 in front of the x squared today. All right, so just key idea here. Remember your sum and product. We're looking for two numbers that multiply to the a times c and add to get the b term. So try this example. Decompose the middle term. For the first one, I'll get you started. You're looking for two numbers that will add to negative 5. So negative 5, that's the b value. And that will multiply to whatever 2 times negative 3 is, which is negative 6. All right, so I would think 1 times 6 multiplies to 6. A 2 times a 3 multiplies to 6. I think those are our only integer combinations. Because we're multiplying to a negative, I know one has to be positive and one has to be negative. And since I'm adding to a negative, my larger number has to be the negative one. And out of this combination pairs, a positive 1 and a negative 6 will add to negative 5. So that tells us, so we're going to break this into a 2x squared. The minus 5x will become a plus x, plus 1x or plus x, and then a minus 6x and a minus 3. And then I'm going to pair up my terms and common factor the pairs. So in the first pair, x is common, leaving us with 2 x's and a plus 1 when I divide x out of those two terms. And for the second pair, I want a positive 2x in my bracket, so I'm going to need a negative, and a 3 is common. And that would leave us with a 2x and a plus 1. All right, and now we're almost done. That means 2x plus 1 is common to both pieces, so I'm going to common factor 2x plus 1 out. Plus 1, and that leaves me with a factor of x, take away 3. So why don't you try the next example or two and see how it goes. I will go to the next slide, and in the meantime you put me on pause. I will go to the next slide and do the next answers. Okay, if you check your answer for part B, I went through my multiples of negative 12, and negative 12 came from multiplying the 3 and the negative 3 and the positive 4, and I'm adding to the positive 4. So I have my combinations here. The negative is what I'm multiplying to, so I know my two signs have to be opposites, and because I'm adding to a positive, my bigger number has to be positive. So here's my combination. I broke it down into these two pieces. That 4x got broken down, I common factored, or factored by grouping, common factored. Second one, I'm multiplying to positive 6. Positive 3 times positive 2 is the positive 6, and I'm adding to this minus 7. Negative 6 and negative 1 were my combination that would add to negative 7 and multiply to positive 6. Broke it down, and there we go. The last example, I'm adding to the middle term, which is a minus 3, and I'm multiplying to negative 40. All right, so my signs have to have opposite signs. One's a positive, one's a negative, because I'm multiplying to a negative. My larger number is going to be negative because I'm adding to a negative. So I could do 1 times 40. That's not going to work. That's going to be a negative 39. I could have 2 times negative 20. Ooh, that's not going to work. That's negative 18. 3 won't go evenly. 4 and 10 work in terms of multiplying to negative 40, but yeah, they don't add to negative 3. 5 and negative 8. Oh, bingo, there it is. Okay, 5 and negative 8 are what's going to work. Now this one's a little bit different because I also have y's with this, but in terms of what we do, it's still that middle term gets broken down. So I have my 10x squared. I have a plus 5. This was an xy, so we have to have xy with this. And then a minus 8xy. So if we have 5xy minus 8xy, that leads us back to that minus 3xy. And then we have a minus 4y squared. We still pair them up for common factoring, that with that. If I look at that first pair, 5 and x would be common, and that leaves me with a 2 and an x. That will give us the 10x squared. I would need a plus. I already have 5 with an x, but I still need a y with that. And then out of the second pair, I would have a minus and a 4 and a y is common. That would leave me with a 2 with an x and a minus y. That would be a plus y, not a minus y. Plus y. Now you'll see that we have 2x plus y and a 2x plus y. So that's our common 2x plus y. And our other bracket would have a factor of 5x and a minus 4y. Okay, so not a whole lot different other than we've got the y's added in with that. So hopefully that makes sense, and you can continue on to the other side.